What is the multiverse? Can modern physics reveal the deep mysteries of the nature of reality? Or realities?
The word universe meant everything, the totality, every star, every galaxy, the whole shebang. So what sense could there possibly be in having more than one everything? And what we have found in research that actually dates back a number of decades, but most vigorously relatively recently, is that our mathematical investigations are suggesting that what we have thought to be everything may actually be a tiny part of a much grander cosmos. And that grander cosmos can contain other realms that seem to rightly be called universe, just as our realm has been called universe, which means that you have many universes, multiple universes, which we call the multiverse.
Physicist Sean Carroll claimed that our universe would have to be in an isolated island universe in order for it to not interact with other universes. Otherwise, our universe would be affected by the ripples from bubbles of another universe that it bumps into as it passes by. Multiverse models are problematic because they cannot explain why the Big Bang happened at all, or why the laws of physics are as they are today, which seems to follow from mathematical constants.
So how can you gain confidence in an idea that speaks of realms that we can't see, that we can't touch, we can't visit, we can't observe directly? In some versions of the multiverse, there can be subtle connections between the universes that might allow us to have some experimental window onto them. But hold that to the side for the moment. Let's think about the ones where you couldn't visit them. Well, why do we think about these things? Well, we have a belief founded upon really hundreds of years of experience that math can provide a gateway to reality. It can provide a window onto a reality that at the moment the math is being done, we can't actually see or observe that reality. I mean, Einstein is the greatest example, right? He wrote down his equations of the general theory of relativity way back in 1915. Others looked at those equations and found that they seemed to say the universe should be expanding. The math said the universe is expanding. Einstein himself said, no, I don't actually believe that. But 12 years later, observations showed the universe is expanding. The math was confirmed by observations. Other examples are black holes. Again, Einstein's math gives rise to them. Einstein didn't believe it. Observations now show that there are black holes. So we're following in that tradition. We are doing mathematical equations, following them, and as we can discuss in some specific cases, they are leading us root by root to the possibility that ours is only one universe. Does that mean the math is right? We don't know. It has to be confirmed ultimately through some kind of observation or experiment, but the possibility that the math is revealing this new picture of reality is sufficiently compelling that many physicists, including me, are taking it seriously and investigating it vigorously.
The concept of multiple universes depends on the conception of reality as a four-dimensional space-time continuum, which everything that could possibly happen does happen in some universe. It is often misinterpreted as implying there exists many copies of you, and indeed there are different possible versions or replicas of you in other universes, similar to how different possible ways for you to watch this video can be imagined as occurring in parallel worlds. However, this idea is more easily understood by considering non-trivial quantum mechanics examples such as Schrödinger's cat. Schrödinger's cat can simultaneously both be alive and dead, but such states are never observed because they do not remain stable. Instead, superpositions, or coherence, between classical states break down into one state or another, collapse of the wave function, by interaction with their environment. Following this example, since the cat is neither alive or dead, it is reasonable to say that it is in a quantum superposition of both states. However, if we assume the many worlds interpretation of quantum mechanics is correct, all quantum coherent superpositions, including those of Schrödinger's cat, exist as real physical entities in distinct parallel universes, in which every possible outcome happens. And if we consider an electron that can have two different spins at the same time, then this means there are actually two electrons with two different spins simultaneously, one spin-up electron and one spin-down electron, in distinct separate parallel universes. In some interpretations of quantum mechanics, this interpretation further implies that all possibilities are realised. Subsequently, every possible outcome will happen in a parallel universe. Thus, there will be an infinite number of universes that exist, containing duplicates of every physically possible circumstance.
By mathematical investigation to imagine the Earth is not the center. And then others, using similar kinds of reasoning, noted that the Sun is actually not the center either. And then similar mathematical reasoning showed us that our galaxy is not the center. It's one of many, many galaxies. We've gone through a sequence of, if you will, cosmic demotions. We may be on the threshold of the next demotion by following exactly the same pattern. Earth is not the center, Sun is not the center, galaxy is not the center, our universe may not be the center. It may be one of many universes following exactly the same pattern.
The multiverse hypothesis has been criticised for a number of reasons. Some physicists claim that the multiverse hypothesis is not falsifiable and therefore not scientific. In response, defenders claim that the multiverse is testable, and some suggest it may be more scientific than certain other untestable theories. Some proponents of the theory say there are an infinite number of conceivable universes. However, cosmologists such as Max Tegmark argue that only universes with matter could be realised. According to quantum mechanics, universes without any classical space and